Okay, we're going to take a look at lesson 8.5, variation functions. Make sure that you take out the worksheet that's in along with the 8.4 notes. There's a couple worksheets with practice 8.5 variation functions. The first thing we need to do is figure out, define direct variation and some of the other variations that we'll be dealing with. Um, direct variation, it's like a linear function. Y equals k times x, where k is the constant of variation. So we're multiplying by the constant of variation when we're talking about direct variation. Um, we've seen that with linear functions before. That's what direct variation works with. Joint, so this is going to be direct, is going to be multiplication. Joint is more than one multiplication. So it might look like y equals k, again, is a constant of variation. That's what we'll be solving for. And it might be times x times m. This would mean that y varies jointly with both x and m. And again, that's more than one multiplication. Inverse variation, we just took a look at inverse functions in their graphs, and that was 1 over x, or in this case it'll be k over x, where k again is the constant of variation. So this has to do with division. Look at it that way. Combined is going to be both multiplication and division. So if I said that y varies directly with x, while inversely with m, it would be y equals k times x divided by m. So this combines both multiplication and division. Okay, so grab your worksheet and we'll take a look at these first couple of problems. State whether each equation represents a joint, inverse, or combined variation. So the first one, u equals 8 times w times z. Oh, we also have to name the constant of variation. So in this case, we have multiply, so u varies directly, or u varies jointly with w and z. So we would call this joint variation, where k is equal to 8. P equals 4 times s. That would be the perimeter of a square. 4 times the side length. Where we have direct variation, it's 4 times s. So we could say direct, and we would say that k equals 4. This is L equals 5 over k, so we're taking our constant and dividing by the variable. Since it's division, we would call that inverse. The value of the constant, we shouldn't use k here, so what is the constant of variation? The constant of variation is equal to 5. This one's a little bit different. We have x times y, so we could solve for the constant of variation in these other guys here. You could solve for k here. If you solved for k, we would divide both sides by x, divide by x. So direct variation, k is equal to y over x. If I did this times x, k equals x times y. So sometimes they disguise them, trying to trick you here a little bit. So if I divided by x and divided by x, this makes it a little easier to deal with. Y equals 4.5 over x. Now you can clearly see that it's inverse, and our constant of variation, or our value of k, which we usually use, is 4.5. Next couple, again, this is very similar. Circumference divided by diameter equals pi. Pi is just a number, so it's 3.14. So this would actually be c equals pi times d. So we would know that it's direct, and our constant of variation is pi. This one is a little bit different in that you could look at it kind of two ways. I would look at it as we need to get it by itself, so D equals 1/2 M times N, and this is double multiplication, so we would call that joint, and we would say that the constant of variation is 1/2. If they wanted us to solve for one of these other variations, then it would be combined and the value would be 2. But that's a little bit of a, they should identify which one they want us to solve for. This one, we're taking the constant divided by g, so h varies inversely. So we got inverse, k is 1 1/4. And then the last one, we could rewrite this as 3/4 times 1 over x. So it's, again, it's inverse. And my value of k is 3 over 4. So we're kind of looking for, are we multiplying by our constant? Are we dividing by our constant? Do we have a double multiplication, or do we have a combined both of them? We're just going to do a couple of the problems on the front side here. Start with number 10. Y varies directly with x. The first thing I like to do in a situation like this is write an equation. If y varies directly with x, then we can say y equals k times x. It told me that that's the one I'm going to use because it says directly. It says when y is -16, x is 6. So this is just like solving y equals m times x, where we're going to solve for k. So I have -16 over 6. Maybe we would rather use -8/3. Now I can solve any equation that says find x when y is -4. Take this over here, y is -4. I solved for I solved for k, -8/3 times x. So all I did was substitute in. I substituted in the value of y that they gave me. I substituted in the k that I found. And now when we solve, x equals -4 times -3/8. And when I multiply -4 times -3/8, I should end up with x equals positive 3 over 2, or 1/2. Excuse me, 1/2. So we're just solving for x. So we use the given information over here. Step 1, solve for k. Over here, use what I found to solve for what's missing. Varies jointly. I'm skipping down to number 15. Varies jointly. Y varies jointly with x and z. So I'm going to write y equals k times x times z. Remember, jointly is more than one multiplication. It says when y is 12. That means that we can solve for k because I know x is -2 and z is 3. Solve for k. I get k is -2. Okay, now we're going to go back. It says find y. Y equals, again, I know my value of k is -2. X, I'm just plugging into this formula now. I know that this is the formula that I'm allowed to use because they told me jointly. Y equals -2 times x is 4 and z is -1. So I get y equals 8. Yeehaw. Again, step 1, solve for k. Step 2, plug in the known values with your new k, and you're good to go. 16. Y varies inversely as x. Well, y equals k over x. We know that's the formula for inverse because k is my constant of variation and x is my, you have to divide because they said inverse. So again, y is 16. It says x is 4. Solve for k. 16 times 4 is 64. Once you have that k is 64, I can go back and say find y when x is 3. Y equals 64 over 3. And and 64 over 3 must be about 21 1/3. Does that sound right? Yeah, I think that works. Again, step 1, solve for k. Step 2, go back in and figure out what they're looking for with the given. Here we go. We got a combined for number 18. Skipping down to number 18. Y varies directly as z, inversely as x. So I can do k times z over x. Plug my value in for y. Plug my value in for z. Plug my value in for x. I got 18, I got 3, I got 6. 3 over 6 is 2, or 1/2, so I can multiply by 2 on both sides, because that's 1 and that's 2. Boom, boom. Ain't it great to be? Negative 36, again. Now I can find y. My value of k is negative 36. My value of z, I'm getting that over here now, is negative 5, and my value of x is 5. Ooh, ain't that wonderful? I got a negative times a negative. 5 cancel each other out. I get positive 36. So that's a combined which has both direct and inverse. Notice they have to tell you which one's direct and which one's inverse so that you can put them in the right spots. So we get 36. So that's kind of an example of each one of the 4. Now, of course, we can't get away from word problems because they're wonderful. It says the volume of a gas V varies inversely as its pressure P. So I got B equals K times P. Oh, they told me inversely. This isn't multiplication. Inverse means division. So I need to put it over P. If the volume is 80, when P is 2,000, then I can solve for my constant of variation, and I get K equals, that must be about, holy cow, a big old number, 160,000 if I multiply both sides by 2,000. And now it says find V. I'm looking for V. I know my constant of variation is 160 grand, and we're going to divide by 320 millimeters. So I get a volume equal to whatever 160,000 divided by 320 is. That must be about 500 if I've calculated correctly based on what I know about 160,000 and 300, and this was a volume, so this is centimeters cubed. So this is not a lot different from the problems that we just did. Step 1, solve for your constant of variation. Step 2, plug in and find what's missing. The length S that a spring will stretch varies directly. I heard direct variation. S equals K times weight F that is attached to the spring. If a spring stretches 20 inches with 25 pounds attached, how far will it stretch with 15 pounds attached? Now you can do this one just like we've been doing, where I can do I can do 20 inches for the stretch and 25 pounds for the weight, and we can solve and get the value of K is equal to 0.8 or 4/5 and then go from there. But you can also do these direct variation ones with the fact that K is equal to S over F, and it has to be equal to 15 pounds. And what are we looking for? We're looking for the stretch with 15 pounds. You can cross multiply this. You know, there's more than one way to do a math problem. And 20 inches over 25 for direct variation. Because if you think about it, what did we do when we did K over here? We did stretch divided by F, the weight. And then we just simplified 20 over 25. Well, 20 over 25 has to be equal to the stretch over the 15 for the other one. So we can cross multiply and solve, or I can do what we've been doing, which is solve for S, which is equal to my constant of variation times 15 pounds, which is equal to, must be about 4 times 3, which is 12 inches, which if we did 20 times 15 divided by 25, hey, we get 12 inches. Isn't that wonderful? Last one, geometry. The area of a trapezoid varies jointly, more than one. Area of a trapezoid varies jointly, which means jointly as its height, k times h, and the sum of its bases. This would be base 1 plus base 2. If the area is 480, when the height is 20 and the bases are 28 and 20, what is the area of trapezoid when it's 8? Height is 8, and then my two bases are there. So again, we can solve for this guy here, 20 times 48, which means I get 480 equals k times 960. Holy cow, if you paid attention in geometry, you would have known the formula for a trapezoid. It is equal to 1/2 times the height times the sum of the bases, which we all long for the days of geometry. 1/2, now they give me a height of 8. They give me bases of 10 and 15. And if I do this, it's 4 times 25. It's 100. And those are going to be meters squared. So this is just another way to take a look at the area of a trapezoid formula based on what we know about height, two bases, area of it. We can solve for k. Step 1, solve for k. Step 2, use your k and your other known values to solve for what's missing. Some lovely algebra is going on here. If you turn your paper over, you get a couple of more problems here that can be done. The height that a diver leaps above a diving board varies directly. Height equals varies directly with the amount that the tip of the diving board dips below the normal level. So maybe D for dip. If a diver leaps 44 inches, that's going to be the height. When we have the board dips 12 inches, boom, you got a constant of variation is 44 over 12. Simplify if you so choose. Must be about 11/3. Now they want to know how high will the diver leap above the board if the tip dips 18 inches. I'm looking for a height, and I have my 44 over 12 times 18 inches, because that was my dip. So we just need to do 44 over 12 times 18, and I think we get 66 inches. We will be able to go up 66 inches. That's a long way up. Holy cow. It's like 5.5 feet. Parking lot design tells me that in the general rule, the number of parking spaces in a parking lot for a movie theater complex varies directly with the number of theaters. So I know that my parking spaces, varies directly with the number of theaters. It says a typical complex has 30 parking spaces for each theater. That's 30 parking spaces times each theater. This is actually K. We actually were given K in this case because I need 30 times every theater is equal to the parking spaces. Business wants to have 210 parking spaces. How many theaters should he have? So I know I have 210 equals 30 times T. T is 7. An apartment rents for M dollars per month. If N students share the rent equally, how much would each student have to pay? How does the cost per student vary with the number of students? So we're talking about M dollars divided by N students. That's going to be our constant of proportionality. So this is direct variation because it's money equals K times N. So it says if two students have to pay $700, that means we have a total of $1,400 for two students. So I have 1,400 divided by 2 equals K. K is $700. If there was 5 students instead, then we can go ahead and say 1,400 divided by 5 equals $280. Again, this is more of a common sense exercise than anything else. Last couple, the cost of painting a wall varies directly with the area of the wall. So my cost equals K times area. Write a formula for cost of painting a wall with dimensions L times W. Well, that's going to be K times the area of the wall is length times width. So this is jointly more than one multiplication. So I think I answered the question right there. And this last problem, this hydrogen problem, the cost of a hydrogen tank. The key one here, it says that the hydrogen storage tank varies directly with the volume of the tank. So I know that I'm going to have volume is equal to K, or the cost varies directly, excuse me, cost varies directly with the volume. There we go. Cost equals K times V. Now this V is length times width times height. So fill in the missing spaces in the table. Well, the known values are here. So 24 times 24 times 24 yield a cost of 800. So you can take that 800 and set it equal to some constant times 24 cubed. This is going to be a very small decimal if you think about taking 800 divided by 24 cubed. If you grab your trusty calculator, I think you get like 0.05787. That's the constant of proportionality that we can use for any of this stuff now. So I've got 0.05787 times the volume. That's what's going to give us our cost. So the next, the top one, I can do 36 cubed times this constant of proportionality, because here's the volume, length times width times height. So when I do 36 cubed and multiply it by this guy, I get 2,700 bucks. And then when I take 150 and set it equal to my constant of proportionality, also known as the constant of variation, times 18 times W times 24. So I can take this guy times 18 times 24 times W, and I can solve for W. And if you take 150 divided by that product, you're going to get 6. You can do it on your calculator, or you can take my word for it. It's really up to you. Next one, the hydrogen tank must fit on a shelf that has a fixed height and depth. How does the cost of the hydrogen storage tank vary with the width of the tank with fixed depth and height? Well, the only thing that's going to change, cost equals my constant times length times width times height. So if we're talking about this being fixed and this being fixed, then this is the only variable, and these three together now become the constant of variation, which means this is still direct variation. And then how much would a spherical tank of radius 24 inches cost? First thing you need to know is how to find the volume of a sphere, which is 4/3 pi r cubed. Well, the cost is still going to be equal to this same constant times 4/3 pi r cubed. Work that sucker out, and I think you get 3351.03. Okay, direct variation, constant variation. Enjoy. Have a wonderful day.